Hello everyone, welcome to my YouTube channel again. So today in this video, I will be covering the Retrieval Augmented Generations Day 2. So previously I actually covered the RAG pipeline. So if you do not watch my previous video, please into this same playlist, watch my previous videos. So basically here I actually covering the data indexing process. So how we will actually index the data. So if I go to the RAG pipeline, like how it actually works, like we have the data, documents, and the vector data. So those documents are actually upsorted into vector database. Then whenever user asks any query, we fetch the top K results from our vector database. Then we pass it to any LLMs. It can be open source or closed source. And then the LLM finally gives us the response. So let's just continue for data indexing process, how we actually index the data. So for data indexing process, there are different steps involved right now. So first of all is that data loading. So this involves importing all the documents or information to be utilized. So basically the data that are stored in our personal data storage, which can be our local storage or any cloud platform. So this is our private data. So we need to actually first load the data. After loading the data, we will split the data. So how we will actually splitting the data? For example, I showed you earlier, we have a PDF file which is involved 100 pages. So and each of the PDF file contains 100 words, and if we multiply 100 by 100, it equals to 10,000 words. And similarly, if we have 100 PDF files of the same length of pages, it will be about 1 million words. So we need to split the words in terms of upsorting the vector data into vector store. So that's how the data splitting actually occurs. So large documents are divided into smaller pieces. So smaller pieces means smaller chunks. For instance, sections of no more than 500 characters each. So we will split the data in a way that each of the chunk doesn't contain no more than 500 characters. So after splitting the data, we will go to the data embedding part. So data is converted into vector from using an embedding model. So embedding model that I actually covered the previous videos, basically they are converting the text into numbers because large language models cannot understand textual data. So we need to make sure that whenever we are converting the when we are actually passing the data into LLMs or storing into vector store, we need to convert them into numbers. So that's why embedding model comes in, and then making it understandable for computers. And then the data storing part, these vector embeddings are saved in a vector database. So the vector database that I actually talk about, any open source vector database that can be right there. So for example, ChromaDB, Llama Index, something like this. Or if we talk about more scalable or paid vector databases, Pinecone is one of them. So we can also use this. So it depends on depends upon your applications, like how large your data set is, and also the business requirements, and that allowing them to be easily searched. So whenever the user asks any question, so for example right there, so whenever the user asks any question, we create the same vector embedding that we have used previously for data indexing, and then we search the vector database, then it retrieves top K results based on our user query. And then we pass the user query as well as the top K chunks to LLM, then LLM gives us the final generation. So here the data storing, that how it actually works, and then retrieval and generation process. So it involves two things. First of all, retrieve the information based on the UR query, and the generation. So the large language model will finally generate the final response. So when a user asks a question, first of all, user's input is first transformed into vector. So vector means vector database. So or use a query vector using the same embedding model from data indexing phase. So in the data indexing phase, the same query embedding model that we have used, the same embedding model that we will be used right there. And this query vector is then matched against all the vectors in vector database to find most similar ones using Euclidean distance or cosine similarity or dot product, any kind of measurement that we can use right there that might contain the answer to the user questions. This step is about identifying relevant knowledge chunks. And then finally, after getting the retrieval sections, then comes to the generation process. The LLM model takes the user question and the relevant information retrieved from the vector database to create a response. This process combines the question with identified data to generate an answer. So finally, the LLM gives us the final response. That's how it actually works. So if I go to the full process, so you can see this is the data indexing part and this is the retrieval and generation part. So yeah, I think that's the retrieval and generation process and also the data indexing process. And in the next videos, I will be covering a practical implementation about RAG, like how basic RAG application works. And in the further videos, I will be also covering different advanced RAG applications, like how we can actually deal different kinds of data sets and how we can make the query efficient in a way that whenever it pull out the information from the vector database, we will make sure that it gives us a more precise and consistent results. So during these slides, I actually take these particular things from this Medium article, so you can actually go through this article. I will attach this link into the video description, so you can also read this article. So I think, yeah, that's all from the data indexing process and retrieval and generation process. So stay with us. Thank you.